Dr. Ranjani Parthasarathy is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures on computer architecture. In today's lecture, what we will do is take a look at the overview of what goes into a computer and try to look at a little bit of details on each of the components that are there and try to understand a big picture view of what is really happening in a computer from, of course, from the architecture point of view. So, to look at the familiar big picture that we talk about, this is referred to as the von Neumann model. I am sure most of you will be familiar with this kind of a picture of a computer system. That is, we know that we will have an input unit, an output unit, a processor unit and some memory and storage. So, we know the data will come from the input to the processor processes it, maybe it will store it in memory and then an output will be produced, which and there is an input interface and an output interface which connects up the input to the processor and the processor to the output. So, now what we will do is we will just take a couple of minutes to look at this picture with respect to the familiar PC that we have. So, let us just try to list down the PC components and identify which of these components map onto which of these 4 modules. So, I will just read out these PC components. In your mind, I think you can try to see which of these map to the various components that we talked about. So, we have the processor, we have the cache, then you have the SDRAM or DDRAM, we have PCI bus, hard disk drive, CD-ROM or floppy drive or DVD, keyboard, mouse, joystick, scanner, monitor, graphics adapters, sound card, microphone, speakers, network adapter, printer, plotter, I/O ports, serial I/O port, parallel I/O port, USB ports and so on. So, if you look at these different components that have been listed here and if we just go back to this big picture that we talked about, we should be able to identify whether it is a processor element that we are talking about, whether it is a memory or storage element, whether it is an input device, an output device or whether it forms part of the input interface or the output interface. So, this we should be very easily able to identify, so that we understand from a PC point of view how it maps to this von Neumann model. So, let us go back to this list of components again. So, processor, we definitely know where this belongs, this is the processor that we are talking about. Cache, this is part of the memory structure. SDRAM, DDRAM, part of the memory structure. PCI bus is more of an interface kind of a structure. This could connect up either the input or the output or the memory to the processor. And then we talk about hard disk drive, clearly this is a memory structure. CD-ROM, floppy drive, DVD, all these are storage devices. Keyboard, mouse, joystick, all input devices. Scanner, again an input device. Monitor, it's an output device. Graphics adapters is an interface for an output device. Sound card, microphone, speakers, again we are talking about input and output devices and if you have, when you talk about sound card, we are talking about a interface device. Microphone and speakers, microphone will be an input device, speakers would be the output device. Network adapter similarly, it is both an input and an output device interface because you are able to connect to the network both for input as well as output. Printer, plotter, these are output devices. Your I/O ports, serial port, parallel port, USB port, these are the interface for input and output. Okay. So, so if you open up a computer now, at least you should be able to identify these different components and say that, okay, I know that this is the processor, these are the different memory units, this is the input unit, this is the output device, these are the interfaces that we have. Okay. So, now you have this big picture. Now, let us zoom in a little bit and try to understand how data actually flows between these various components that we are talking about. So, if you look at this simplified organization of what is there in the processor, now you can see that here I am showing a different kind of interconnection between the 4 different components that we talked about. We talked about control processor, the control and the processor which forms the central processing unit. Then we have the memory, input and output, and typically we have some kind of an interface, right, a bus kind of an interface which is normally used to connect up these 4 different components. It could be a bus like structure or it could be a some other different interface, but to understand things, it is very easy to understand it in terms of a bus. Now, what do you mean by a bus? It is just a set of wires which carry some signals, that the signals could be either data or it could be address or whatever it could be, or it should be some control information, but some signals which are used to connect up these different units that we have. So, you could have data flowing in from any unit to any other unit. So, you will have data going from input to the control unit. You could have data coming from control unit to memory or from memory to control, and you could have data going from the control processor to the output, and all these are facilitated by means of this common bus like interface. This is a very simple organization that we can look at and try to understand what exactly happens when we say that a program is executed or the instructions in a program are executed. Okay. So, now a little bit on each of these modules that we talked about, right. First, let us take a look at memory. What is memory? We normally look at it as a one-dimensional array of electronic registers, each capable of holding a binary number. So, these are called memory locations or cells. So, when we talk of memory, we know that we normally talk about memory cells or memory locations, and there is some data that is stored in each of them, which means that every cell that we talk about has some kind of an address. So, we say that each of these cells has an address, and typically the smallest addressable cell is called as a byte. That is to say that we normally look at the units that we are talking about in terms of bytes. Byte, we know this is a 8-bit number. Okay. So, 8 bits together is treated as one cell, and for every cell normally we have an address given. So, you have locations or addresses, locations and addresses for each of these locations. So, we can look at locations or cells as 8-bit units or bytes, and addresses as addresses for these bytes that we talk about. So, this is typically what our view of memory would normally be. Okay. We can also organize memory into larger units. So, for instance, it may not be just 1 byte that we talk about, but we may talk about 4 byte blocks or a 32-bit unit. So, in that case we refer to them as words, okay, and we say that you have a word which consists of 4 bytes, that is a 32-bit word can be treated as 1 unit and a 32-bit word can be treated as 1 unit which consists of 4 bytes. So, this can be treated as one block. Often when we are actually working on on any system, you will find that you may not be accessing only in terms of a single byte, but you may be accessing data in terms of 4 bytes, 8 bytes and so on. That is, you are looking at larger blocks or larger chunks of memory being accessed. Okay. This is something that we need to remember. Okay. So, if you look at how a memory operation typically takes place, that is, you have a processor which needs to access something from memory, right. So, which means now we said that memory is organized in terms of addresses and each address will point to a location. Now, there is some data which is stored in this location. So, what we need to do is you need to specify the address, and from the address whatever data is located at that address you need to be able to retrieve. This is when I am reading data from memory, or I may write data, that is I may store data into memory, in which case I will specify the address and I will specify what data needs to be stored there, and that will have to be stored into memory. So, this is what we mean by doing some operation on the memory, that is I may either read from memory or I may write to memory. The normal terms we use for this is we say we are loading from memory when you are reading from memory, and we say we are storing into memory when you are writing to memory. So, loads and stores are the typical operations that we talk about. Okay. So, in order to do this, let us look at what will actually be there inside the in the interface to the memory. Okay. So, if you look at the interface to memory, you can see that there will be normally 2 pieces of information which are stored in 2 registers, one called the memory address register MAR and another called the memory data register MDR. So, now from what I just told you that we need to specify an address and a data, you can easily map and say that the address would normally be specified in this memory address register, and the data that you need to write or the data which is retrieved from memory will be available in this data register. Okay. So, if you look at this typical sequence of operations that we need to do for a read or a write operation, this is what it would be. So, if let us say I am doing a write operation, what do I need to do for that? I will specify the address in the memory address register. So, which means I will load an address into this memory address register. I will load the data into the memory data register, say that in this address this data needs to be written, and then of course, you need to give a command to the memory to store the data, saying that it needs to write this data which is available in the memory address register into write the data which is available in the memory data register into the address which is available in this memory address register. Okay. Similarly, if you were to read from memory, what is it I would need to specify? I will only specify the address. So, you load an address into the memory address register and tell the memory, give it a command to fetch data from that memory address, and the contents of the memory location will be fetched from memory and they would be stored in the memory data register. So, this memory address register and data register serve as the interface between the processor and the memory unit. Okay. So, this is what will typically happen in terms of a memory operation. We can understand that from a schematic kind of a representation. So, if you have your memory here, right. So, this memory interface will have these two parts, memory address register and a memory data register. Note the direction of the arrows over here. So, you have data being written to the memory, there is some value which is being stored into this memory address register, and this address goes as an input to the memory. Data register, if you look at, you can see that there are arrows on both sides, which means from the memory data register you will have data being stored into memory or data being read from the memory into the memory data register, which is why we have these two arrows in two different directions. And of course, there will be a control that needs to be specified. We know that this control is the one which is going to specify whether it is going to be a read operation or a write operation. So, if it is a load operation, that means I am trying to read from memory, you would be specifying I will load this value with this register with some value and give a read command. So, data from that location will be stored in this data register and that can be accessed by the processor. Okay. Similarly, if it is a store operation, the processor will make sure that it gives the address here and the data here and give a write command, and in this address location this data will be stored. Okay. So, this is what would happen with respect to a memory interface and a memory operation. Okay. So, now let us look at what goes into the processing unit. Okay. Now, the processing unit, this is the core of the entire processor, right. So, this processing unit normally comes in many shapes and sizes. Okay. So, let us first look at one of the typical units which is normally there in this processing unit, which is the arithmetic and logic unit. That is, we need to perform arithmetic operations and logical operations. So, we have what is called as an arithmetic and logic unit, which typically has the following capabilities. You should be able to add two numbers, subtract two numbers, you should perform logical operations like AND, OR, XOR, complement. These are typical capabilities that you would normally find in an ALU. So, you would have in your course on digital or whatever, you would have studied about how to construct an adder, how to construct a subtractor and so on. So, these adders and subtractors that we talk about are what actually form this ALU. So, you have multiple such functions that can be done, right. You have an addition operation, you have a subtract operation, you have an adder unit to do the addition operation, a subtract unit to the subtract operation and so on. So, these units together form the ALU or the arithmetic and logic unit. Again, depending on the complexity of your processor, you may have additional functions that are added in this. You could have, for instance, a multiply instruction, and you could have a multiply operation that is supported, which means I have a multiplier as a functional unit which is there inside my processor. So, depending on the functions you will that you want to support, you would design your processor accordingly. Okay. So, in simple terms, let us just assume that we have some arithmetic and logical unit and try to understand things from that perspective. So, if you look at an ALU, this is how we normally represent an ALU. Okay. It has this particular shape that we normally use. So, it will have, so if you look at ALU, you will specify the inputs to this arithmetic logic unit, and this is the output that is produced. And you will again have control units here, control signals here, which will specify what is the operation that needs to be performed on the inputs. So, we refer to these as input operands and this as the output operand. So, we have to specify which are the input operands, and we will have to specify what is the operation that needs to be performed on this input operand. Okay. So, in this case, if you say add, for instance, is given as a control signal. So, what will be produced will be the sum of A and B. So, A plus B is what will be produced here. If sub was the control signal that was given here to this block as a whole, it would produce A minus B. What would actually happen is that inside this ALU there would be an adder and a subtractor, and depending on whether you choose add or subtract here, the corresponding functional unit would be chosen and the appropriate output would be produced. Okay. This is what would happen in an ALU. Okay. Now, coming to input and output devices. Okay, let us just consider a simple case of input as a keyboard and output as a CRT to just understand what is happening here. Okay. So, input is our keyboard, output is the CRT. CRT is your monitor that we are talking about. So, of course, we will look at a lot more input and output devices when we go towards the end of this course. So, but right now, to keep it very simple, so what are we looking at? Individual pieces of data bytes can be sent to the monitor and received from the keyboard. Okay. So, once again, how do I send data to the monitor and receive data from the keyboard? Again you will find that there will be some registers through which you will be able to talk to these devices. Just as we talked about memory when we looked at memory, we saw that there is a memory address register and a memory data register. Similarly, for each of the input output devices, there is an interface, right, which controls how you actually talk to these devices. That controller typically will have some registers in it. So, these registers will be used as input output registers. So, the processor will be able to write to these registers, and from the register it will be shown onto the monitor, or if it is a keyboard that we are talking about, an input device, the input device would store the data in that register, and from the register you will be able to read. Okay. So, this is what happens in terms of input and output devices. Now, coming to the control unit. Now, we have got this memory unit, we have got the input output units, and we have the ALU. All these we saw require some control signals that need to be given. So, who produces all these control signals? It is all produced by the control unit. Okay. So, the control unit therefore is a very important aspect of the entire processor. So, what is this control unit? How does it do it? What does it do? These are things that we need to understand next. Okay. So, if you look at the control unit, you can generally say that it is responsible for producing commands or giving commands to the other components to perform their function at the appropriate time. Now, this is very important. That is, we always need to do a sequence of operations in order to achieve a task. We have seen that a program basically is a sequence of instructions. So, a sequence of instructions will have to be given to the processor, and the control unit has to make sure that the sequence of instructions are executed in the correct order. Okay. So, sequencing and making sure that these different components perform it in the correct time, this has to be taken care of by the control unit. Okay. So, how does the control unit do this? Again, it uses some set of registers to keep track of things and to get things done. Okay. So, one of the important registers here we talk about is what is called as an instruction register. Okay. So, an instruction register is the one which will contain the instruction that is currently being executed. Okay. This is one important register. Similarly, we have something called a program counter. Now, this program counter will keep track of what is the address of the next instruction to be executed. Okay. So, one keeps track of the address, so which means this is used for sequencing things, and instruction register is the one that keeps track of what is the instruction that is currently being executed. Okay. So, based on these two registers, the control unit is able to sequence and make sure that the components perform the operations correctly. We will take a look at the details of this after a small break. Welcome back after the break. So, we were just talking about the different components that we have, that is, we talked about the memory unit, the input output units that we have, what kind of interfaces are required for that, and then we were looking at how the control unit is designed in order to control these different components. Okay. So, as I said, the control unit, there are some dedicated registers which are present in the control unit, which help us to, or which help the control unit to control and make sure that everything happens correctly at the correct time. Okay. So, there are two important registers that we talked about in the control unit. One is the instruction register and one is called the program counter. Okay. Since we call it as a program counter, so you can see that a counter typically will be something which is counting, right. So, this would typically be counting and keeping track of the next address, the address at which the next instruction is located. An instruction register, on the other hand, will have the instruction that is to be executed, and based on the instruction, right, the control unit will be able to produce the right commands and give the correct control signals to the various devices that we talked about. Okay. So, now in addition to the these two special registers that we talked about, the processor or the control unit will also have a number of general purpose registers. Okay. Now, the reason why we have these general purpose registers is that the time that it takes to store or fetch memory is normally long in terms of processor time. That is, if you look at the time at which the processor is able to handle things, it works generally much faster than the time it takes to handle to access data from memory. Okay. So, if I every time have to go and access data from memory, bring it to and then work on it, it can become slow. So, what we normally do is we have these temporary storage called registers, which are kept close to the processor, that is, they are kept very close to the CPU, and then these can be used to store intermediate results. So, for instance, let us say I am fetching some data from memory, I do some operation on it, I may be doing one more operation on the same data, in which case it makes sense for me to keep the data closer to the processor rather than every time fetching it from memory. So, it is for this purpose that we have what are called as general purpose registers. Okay. So, what is normally done is, in order to improve the efficiency of the overall process, we install a small number of general purpose registers very close to the CPU. So, the purpose of this is that, as I said, it allows multiple uses of a variable without refetching every time. Second thing is, it can also allow storage of intermediate results. That is, for instance, let us say you added two numbers, okay, you stored the result somewhere. Now, the next operation you may want to use that result in order to do an operation. So, instead of storing this result to memory and again fetching it back from memory, I can store it in an intermediate result in a register, and for the next operation take it from the register itself. Since I said register operation is faster than memory, naturally the performance will improve, my efficiency will be better. That is the purpose of using these kind of registers here. Okay. And normally what we do is, these registers are grouped together into a device called a register file. So, we normally do not talk about just registers, but we talk about a register file. So, and what we mean by a register file is, it has a set of registers in it, and each register in this register file will be individually addressed, which means I can specify which register I want to store into or read from. You will have normally a facility to do that. Okay. Okay. Now, coming to instructions. So, we said that instructions are what are executed by the control unit, right. So, what are these instructions? So, instructions essentially are some numbers, some binary set of bits, okay, and these instructions are stored in memory. This is typically what happens in our von Neumann model, which we call as a stored program computer. That is, a set of instructions is stored in memory, and we take instructions from this memory, bring it to the processor, execute these instructions one by one, and store the results wherever it needs to be stored. So, if you look at and depending on the instructions that you have, the different operations can be performed. So, what normally happens is that different computers use different arrangements or different types of instructions and different arrangement of instructions, and this arrangement of instructions is what is normally referred to as the instruction set architecture. So, or the ISA as we call it, I for instruction, S for set, and A for architecture. So, we refer to it as instruction set architecture. So, this instruction set architecture is what normally defines the actual, in fact, a lot of times we say that instruction set architecture is what defines the computer architecture itself, because it tells you what are the type of instructions that can be supported and how these instructions will be performed efficiently on a given system. Okay. So, we need to understand what are the different types of instructions which are supported on a processor in order to understand the architecture of the system. Okay. So, if you look at a typical instruction, let us see how these instructions normally are understood. Okay. So, I said instruction basically is just a set of bits, okay, but the set of bits normally have some meaning attached to it. That is, let me take a typical instruction here where I am just going to do an add operation. Okay. So, what I want to do is add the contents of register 2 to the contents of register 6 and store the result in another register, which is called register, it is again the same as the register that I have used here, register 6, or it could be another register also. Okay. So, let us look at what we have here. So, normally you will have one set of bits here which is used as the opcode. Now, opcode is a term that is normally used to specify the operation that is to be performed. So, you can look at it as an operation code. If it was an addition operation, this code would tell me that it is an addition operation. If it was a subtraction operation, this code would tell me that it is a subtraction operation. So, I would have a few bits here which will be used to specify what is the operation that needs to be performed. So, for instance, if I have 0001 here, it could indicate that it is an add operation. 0010 could indicate it is a subtract operation. Okay. So, the fixing of what opcode defines what operation is done by the designer. Okay. So, the designer knows that if this is the opcode, this is the operation to be performed. Then we have the different source registers from which on which this add operation needs to work. So, we know that register 2 has one operand, register 6 has another operand. So, register 2, you can see that this is 010 indicates that it is the second register. 110, we know that that number represents 6. So, we say that this represents the register number 6. So, given that we have only 3 bits here in this structure that we have, this means we may be able to support up to 2 to the power of 3, that is 8 registers, and each of these registers are uniquely identified by means of this register number here. So, I would have a source register specified, another source register specified, and then there may be some bits of this which may not be used, and then I am specifying what is the output register 110, in this case register 6. If I wanted to store in register 7, this value would be given as 111. So, by changing the values over here, and by changing the opcode values, different instructions can be represented. Okay, let us look at another typical instruction. In this case, I am looking at a load operation, load register operation. So, what are we going to do here? I am going to take the contents of register 3, okay, add the contents to the value of 6 to form the address of a memory location. Okay. So, what is it that I am doing here? I do not have the memory location address specified directly, but I am going to take the contents of register 3, add the value of 6 to that to form the address, and then load the contents which are stored in that memory location into register 2. Suppose I want to specify this in a instruction. So, what would happen here is, again I will have a opcode which specifies what is this operation to be performed. Okay. So, this is my opcode, right, and then I have to specify these 2 registers here and this value. Okay. So, you will have fields which allow me to specify these things. So, I have a register 2 which is specified here, right. So, I know that this is the location into which my final result is to be stored. Register 3 plus this value 6, this the value which is there in this register is to be added with this value 6 which is explicitly specified here, and this will give me the memory address. This load instruction will generate the command to the memory, read from that memory location, fetch the data, and it will store it into this register 2. Okay. So, this is how the typical instruction would normally be specified. So, we saw examples of 2 different types of instructions. We will look at more instructions and details of this later, but this is just to give you a feel of what an instruction would generally look like. Now that we have looked at different pieces of the processor architecture, let us look at a complete data path which connects up all these different pieces and see how an instruction would typically get executed. Okay. So, let us look at what we have here. So, you have the control logic here, and I said we will have 2 registers, right, which are part of the control. One, the instruction register where an instruction will be stored, PC, the program counter, which keeps track of what are the addresses from which the instructions need to be fetched, and then we have a register file, then we have the ALU, right, and then we have, for part of the memory, you have the memory address register and the memory data register. So, the different parts that we looked at earlier, you just try to put them all together, and then we can also see that there is a data path and a kind of a bus like structure which connects up these different pieces. Okay. All of them are in some way connected to one another, so that you can transfer data from one of these units to another unit. Okay. So, now given this, let us look at what an instruction cycle would look like and how this instruction cycle would normally get executed. So, if you look at what normally happens in terms of an instruction execution, these are a typical set of operations that need to be performed. First, you will fetch the instruction, that is, we know that the instruction is stored in memory. So, I have to first fetch the instruction from memory, okay. And second, I will have to decode that instruction. What do I mean by decode that instruction? We just saw that an instruction has a particular format, right. You will have an opcode, it will have some various details that are specified. So, we need to know what is the register that I need to operate on, what is the opcode, what is the operation to be performed. You need to understand that instruction. That is what we mean by this decode operation. Once you have decoded the operation, there may be some address that you may need to evaluate. That is, I may need to form, for instance, in the example that we just saw, we said that to find the memory address, I am adding 2 contents of one register and some other value. So, like that you may have to evaluate the address if you need, if it is that kind of an instruction. So, evaluation of address is one other aspect. Then you actually fetch the operands. So, the operands that are required for the doing the operation, they are fetched, and once you fetch the operands, then you can execute and do the actual whatever the instruction is expecting you to do. That is, do the actual operation. If it is an add operation or it is a load operation, that execution would actually take place over here. Okay. Once you have done that, you got the result. So, that result will have to be stored. It may be stored into a register or it may be stored into memory again. Okay. So, all these are the different steps that we normally have in the execution of an instruction. If you look at the instruction cycle, fetch, decode, evaluate address, fetch operands, execute, store result. These will be the normal operations that need to be performed in order for an instruction to be executed correctly. Okay. So, later we will take a look at how, with respect to this data path that we have here, an instruction execution would actually take place. So, to summarize, what we have looked at today is the different components of a computer. We looked at processor, input, output and memory. So, we have looked at the typical model that we normally talk about, the von Neumann model, where you have these 4 different units and data flowing between these 4 different units. We have also identified different elements as in any computer system as belonging to these different or to these 4 units, and then We have seen what a data path would normally look like. We looked at what an instruction format is. We looked at what is exactly how these different units actually talk to one another. We saw that there are some registers and some things which are required for this interface to really happen. We just looked at what are the different steps in an instruction. Okay. So, this is what we have done in today's topic, just an overview or a big picture view of what is there inside a processor or inside a computer as such. Okay. Some questions for you to review today's material. Identify the components that you find in a computer as input, output, interface, etc. So, DVD, LCD monitor, mouse, printer, network card. What are the two registers used to interface to memory? Question number 3. What are the two important registers in the processor? Question number 4. What are the steps involved in executing an instruction? So, with this review, I think you should be able to get a picture of what a computer actually contains. Thank you.